Performance testing, load testing, resilience testing. In 2025, having these non-functional testing skills isn't just a nice to have, it's essential. Learning non-functional testing in 2025 is one of the best career moves that you can make. Hi, I'm Rohit Singh, and over the past decade, I have run non-functional testing initiatives at companies like Soprasteria, VMware, and Broadcom. Today, I run my own business, which is called Populosoft, and we specialize in iOS development and quality assurance as a service. If you are a tester, developer, or just someone who wants to build a better software, hit that subscribe button so you don't miss a thing. Alright, let's jump right in.
Welcome to this lecture on handling requirements and defining tests. So in this lecture, we are gonna take a look at some of the things that come in the beginning of when you start building a test or pretty much a solution. So these are the topics we'll cover today. How do you handle requirements and define tests? What are some vague requirements? How can you build some clear and precise and empirical requirements from vague ones? What are some of the best practices that we should keep in mind when building such a test or a solution? Load models. It's also you're going to have to make a decision about what type of load you want to simulate on the test. So we'll discuss a little bit about that. For resilience tests, where we are trying to make the system fail or recover from failure, things like that. Load models are not that important. So equivalent to load models is failover strategy in my mind. I mean, how do you want the system to fail? What parts of the system you want to fail to see if the whole system can still take up the remaining load. We will try to build a short test. Pretty much like a concept of a test in this lecture today. And at the end, I will share kind of a little task for you that you can try to do at home. It's very, very easy and simple. So don't worry about it. In the coming lectures after this one, maybe next week, I will show you how I tried to do it. It's just to get you thinking about how the memory works, what are some leaks, how can you monitor stuff, things like that. So it will be a very, very simple one. Don't worry about that. So let's talk about how do we handle requirements, and especially the non-functional requirements, and how can we define the tests. What happens in the beginning is when you are starting on a project or when you are working with some requirement analysts, product owners, or project managers, they might request to you that they need these kind of solutions. So they will show you how their system looks like, and they will simply ask you, do you think you can build some performance tests and tell us where the problem is, or where the problem could be in future. This sounds like a good point to begin with, where you can actually, okay, you have the full freedom to choose from A to Z, whatever you want, whatever type of performance test you want to build, you can build it. But the problem is this is very vague. This is not a defined requirement, and you will end up designing a test or a solution which is doing some performance test, but it's not what is going to benefit our customers or what is going to benefit the product decision making, things like that. So another one could be a bit more defined. For example, we are experiencing SLA breaches for several customers in terms of minimum. This happened to me very recently as well. Some of the team colleagues or some of the product people were asking that we have some SLA breaches. We need to have we need to be contained in the SLA most of the time in terms of the response times. Could you please build some tests and find the bottlenecks and maybe help fixing it, help tuning the system in terms of how much memory and the memory, the hardware and software requirements that we need. So these are all pretty much these are sound very tempting to start from here, but we need to be careful when such things come up, because such requirements cannot be worked upon so easily. So what we need to do is to ask more questions and break them down into defined requirements. So let's take an example one from where the product team or the requirement analyst or whoever the responsible person is asks you to build a test. You should explain to them very carefully that whenever I'm going to build a test, it should answer a measurable question. By that I mean it's gonna give you a precise answer to a precise problem, not just running the test for the sake of it. Because there could be tons of different tests built for sure. In performance, you can build any type of test with any number of users, with any type of environment setup. But is it gonna be really useful? That's another story. So um, let's break it down, try to break it down into more meaningful requirements. So for each for each performance test, we should have a defined number of users that are gonna use the application. So first clarify about the users, and if you can ask about users, then ask more stuff like what is the behavior of the users? Do they all come up at once, or they come up one by one, giving some time to the application? Things like that. Do they perform operations at the same time, or their operations are randomly distributed? More often than not, their operations are randomly distributed. The next thing is you have to define what kind of hardware and software setup the customers are expected to use. You should try to begin with something very similar. Another important tip here is to not use empty databases, empty file systems, those things. Try to ask and find out if they're going to have some data loaded, and preloaded data sets, preloaded tables. They can help you achieve a lot of better results than starting up with empty, because empty database behaves completely differently from a filled one, from a full one. The time you will need to write a new row to a empty table is completely different from time you need to write a row to a table which has millions of entries. So always keep in mind to be as close to the client requirements or customer requirements as possible. Then you need to have what type of load models. This is based on the behavior of the user. So are all the users gonna randomly access different type parts of the application, or they are gonna use just one part of the application more often? Things like that. If let's say you have in your application you have a request which is used 80% of the time, then that request should be the one that should be most often accessed in your load model or in your distribution of load. Then come up with the exact numbers, and not just we are experiencing some performance issues, but rather than try to find out the numbers that we are aiming for. So for example, for all requests we are aiming a response time below 200 milliseconds. It's not realistic. So what usually happens is we get something like 80%, like the 80th percentile of response time should be below 200 millisecond. The remaining 20 we can allow to go between 200 and 500 millisecond, or there could be further breakdown, like 10% request can be between 200 and 500, and the remaining 10% can be between 500 and 1000 milliseconds. So once you have these numbers, this is what you are trying to achieve with your whole setup. And at each stage you will need input from customers, from product owners, who are like a bridge between customers and you. So try to communicate as much as possible, find out. The next thing is about the behavior of the test itself. So once you are trying to define a test, you also need to ask how often, like what is the scenario in which we will be using this test. So there could be a test that you build that runs every release, which could be in 2 weeks, let's say, and we could also be aiming for running the test every day. We could also be aiming for keeping the test running all the time. So try to clarify what will be the use case, and always start with the vision that ultimately you want the test to run as often as possible with the minimum resources that are needed utilized, and to report results. So even if you can report the results in 24 hours, it's still a really good starting point for performance tests, because it takes time to actually confirm issues. So if somebody committed some changes in the build and you can report it next day, it's still a really good feature, achievement. So that is how we can break it down. We will try to write like a test, imaginary test in the end, which actually we'll try to write the requirements of an imaginary test based on this. But let's go ahead and talk about performance testing best practices, some of them. So also these need to be in mind when we are building these tests. Um, some of the ones that I have experience from, like that I have understood from my experience, are really important for non-functional tests is here. So the first one is repeatability. If you cannot repeat your tests over and over again, and by repeatability I mean deleting the whole environment, uninstalling the product, if possible also uh, cleaning up the operating system and databases, and then you have to start from there from scratch. If like this stage can be reached a little bit later, where you have the whole stack automatically installed, but as long as you have at least the data being cleaned up and the product being uninstalled, it's also a good feature, good achievement. So you should be able to repeat your test at least 3 times in a row with less than a certain amount of deviation for different type of environments. For example, for cloud, there is usually a little bit more variation between results. So if your response time, average response time in the first round was about 200 milliseconds, it's really hard to get that again on cloud because of several layers of virtualization. But on premise, if you have physical servers, it's a little bit easier to reproduce the numbers because there is less virtualization layers, less things, less variables in the equation. But anyways, always decide a repeatability criteria for the test, because for example, if you run a test, find an issue and report it without repeating it several times, then it's gonna bite you back later when the developers ask you to test the fix or just to reproduce it so they can monitor it, things like that. Another really important point in my mind is it should be as close to the customer usage as possible, but still measurable. So your test, you can define, as I said, tons of tests with tons of different variables, number of users, hardware setup, software setup, scaling up, scaling down, but it's not useful if nobody's going to use it. So because your issue is important, but maybe it will never be uncovered in real production. So, and then there will be some other issues that will happen in the production or in the real use case, but your test was not close enough. And so try to be as close. This will help you decide on a lot of things when you build the test. Uh, Always keep that this will be continuously executed. If you build a test and you don't repeat it often enough, it might not bring enough value. So always try to build tests, and actually once you have a little bit of a stable test, try to put it in continuous execution before you try to build the next test. So the previous test can actually keep giving you value while you work on more building more tests. Once you build continuous execution, fast and proactive feedback will automatically sort of start coming to you, because in my experience, there have been issues where we had a performance issue in a release, and when we tried to actually debug it, there were thousands of commits, and it was really hard to pinpoint which commit introduced it. So if you don't it's a little bit more trickier than functional tests, where you can know the functionality and what's breaking it, but in performance, any layer could be making a difference there in the total performance of the application. So faster becomes even more important. Um, you can one technique that you can use is to use the previous builds, like in a release, go back half the development cycle, take a build from the past and run it and see if there was an issue. But it will be like a binary search, and sometimes you also may not have all the builds ready, so you may have to build the product again from some previous commits, things like that. It's messy, and even after that we were not able to find the problem in the product, like which commit introduced it. So later on we um, decided to compensate for the performance degradation by doing couple of performance improvement stories. So we balance the performance. It's kind of possible in performance test to hide one issue by trying to improve performance in the next ones. Finally, hands-free. It's very important because if you run a test which is 6 hours long, you don't want to wait until 11 p.m. in the night to stop the test and to clean up the environment to check to take all the results and pretty much start another test. It will make your life hell soon if you don't have complete hands-free solutions with such long running or short running or repeating tests. So aim for that. Let's talk a little bit about load models because when you will start building a test, load models are going to be important. So what is a load model? It's like how you are gonna simulate the traffic on the system, the request journey on the system. There could be several approaches. Some of the ones that I have used in the past are here, and there could be more, I'm sure. Each performance testing tool has several options that you can choose from, but you need to start thinking about it to be able to be able to make the right decision. So some tests have a fixed duration. For example, it's useful in the cases where you want to have your runtime of your performance test limited, uh, because you don't have you have a little bit of limited amount of resources. For example, you have a shared lab, you get it for a definite amount of time, then these kind of tests are useful. Another use case where fixed duration could be useful is actually it's a pretty decent benchmark if you have a fixed duration. What fixed duration means is you define that your test is going to run for 30 minutes, and you decide on how you're going to send the request. So you can pretty much combine the remaining stuff. For example, you can have a load of you can have a fixed load like 1000 requests per second being sent to the server for the 30 minutes, and it will be a valid test. um, at the end of 30 minutes, you will be measuring response times. You will be measuring different parameters in the system, like how much was the CPU utilized, how much was the uh, RAM and file system, those kind of things are utilized. Fixed load is when you have, uh, for example, as I said, it's not duration is not defined. You like maybe I can fix this word a little bit. It should be like fixed workload or fixed total workload. What I mean here is, for example, you have 500,000 requests that need to be processed, and you choose that no matter how much time the server takes, I'm going to process these 500,000 requests, and I'm going to see how much is the different variables, what are the results. Like again, you will measure the same things as in the first test, but just the total workload is going to be fixed. It's gonna be this could lead to, like, when you have some performance issues, the server is not reacting fast enough, this could lead to variable amount of times taken for your test. So 500,000 could in case of an issue, it could take an hour if you have an improvement in performance. And this is given that you send requests as fast as possible. But if you send requests as a at a fixed rate, then again it's gonna be more like fixed duration. But if you send the request as fast as possible or any other load like adaptive load, which I'm going to discuss now, then your test duration will be variable. So it's your choice. But the most like one which I liked quite a lot in previous experience is the adaptive load. It changes, it takes feedback from the system, how the system is performing, and adjusts the load according to that. So yeah, adaptive load is, so let's say we have a system that can process about 2000 requests per minute, uh, and it can actually go to 4000 or 5000, but then there could be like a bucket effect in the system. And what this bucket effect is that sometimes the whole systems might hold the files if they receive too many of them for a long time, and then process them one by one, and this will lead to your test looking weird because the system has the capacity to hold thousands, or let's say 500,000 requests, and then it's going to process it at its speed. But when you're going to look at the results, they will look a little weird, because your end-to-end response times will also be weird, because the request that you sent in the beginning, they were on hold for several minutes, and they got processed. So your total response time is really weird. What do you do in this situation? Because the response times you can't really make sense of those, because they are not actually the processing times. There is an additional hold time from when you send the request to when you receive the response. In this case, this adaptive load is really useful. What we need to do is to decide overhead on the system. So how many files at one point we want to allow the system to hold. So if we choose, for example, 2000 as a overhead, or the processing load, then once we have sent the 2000 files, we wait for the system to process at least 500 before we send 500 more. So as soon as we receive the response for the first 500, we need to send 500 more. This will allow us to actually get the response times and not the actual bucketing time or the whole time in the system, and it will be a much better, a much clearer test. This I have used in the past. We built such a thing via scripts. I haven't built such a thing via any of the performance tools so far, but maybe some of them allow it. Via scripts, it's really easily possible, and it's really useful. Spike is just if you know you anticipate that sometimes your users will have a immediate have a great or like huge spike in the performance in the load for, let's say, 2 minutes during the evening or half an hour. If your test is 1 hour and you think that half an hour will be a high load and half an hour will be a lower load scenario, then you can actually try to simulate such a spike. Maybe go like 20% actually higher than the spike to see, because the next day the spike could actually be 20% higher. This will give you more insights on how the system scales up, scales down, what are the performance during the spike, what are the performance, are they back when the spike is down. But scalability is sort of another test, so you may also not try to do all the things in one test. Try to do spike without scaling system. That could be an easier and simpler test. Anyways, for stress test, you go beyond the minimum load, which is like 3-4 times, or as much as you want for breaking the system, which is another thing. Another thing is random versus all the time same. There is also like a ramping up in the beginning. So random, sometimes like the users don't always access a application at the same time. So if your test actually brings them up at the same time and some of the application breaks, it's an issue, but not really like highest priority for all the team to fix it, to be honest, because they will fix it eventually, but probably not with the highest priority. And the same thing with the test. You need such a test to do all the users at the same time, but most of the applications, if you apply too many users at the same time, they will behave strangely. So what we need to do is to randomize the request. So if you have 500 users, somehow make it random, that the first user sends request, then the second one, or they don't always send the request for the half hour at the same times. They are randomly choosing different times to load and download or to send the request. That's another thing to keep in mind. And last thing is applications, when they are deployed, they don't always start uh, um, serving load immediately. So it makes sense to actually build up some ramping up time in the beginning, like a warm up. So start with 5 users, then in the second minute go to 10, in the third minute go to 50, or pretty much like you can go like a linear one as well, every minute adding 50 users until you reach 500, or every minute and using 1,000 users, depending upon the application. So these are the different ways you can imagine how you want to load the application. Uh, some of them are like brutal for the application. Some of them are more realistic. The realistic ones are better, I believe. The brutal ones may not always be useful. um, In performance tests, you have load models, how the things are going to happen. In resilience tests, you just need some kind of load flowing, like some kind of request happening. It doesn't matter exactly which kind of load model you're using. You can choose anyone which is easy enough for you to debug. The real thing in resilience test is how you actually decide to fail or simulate failures in the application. So yeah, this is like in this picture, it's like a resilience test where you're trying to break the phone and you have so many cameras around to see how the phone behaves in this scenario, because this is not a normal use case. It's trying to break the system to find out the breaking point. And the same is the story with the resilience test and how we want to induce failures in them. In software world, if you go ahead and plug like a network cable between your servers physically, it's not gonna help you much, because you can't really do it all the time. Neither can you, like, you can maybe create a bot that is gonna plug network cables to induce network failures. But yeah, we usually do it with software. So there could be some actually good ways around it as well. For example, um, a server may go down in many different ways. It's not like it's always plugged off, it crashes. Um, it, so you need to choose one of the way which is most likely to happen in the client environments. So maybe just shut it down, because it's sometimes but this is like an imagination point where you can actually in the client environment, somebody by mistake shut it down, or there is a power outage, the power is no more in one part of the system. So if you have like a cluster of application which with the multiple availability zones, then you can simply um, create a power outage like sort of scenario, but you need to research exactly to be more realistic than power outage. For example, um, you can create a power outage in different ways, like if the system keeps processing in the has some kind of backup for the first 30 seconds, or it just takes time to shut down, and that may lead to some transactions being corrupted, or it can immediately shut down in like just a second. So try to research a little bit around this. In past, I had to do more like network failures and high latency tests. So network failures, there is applications that allow you to pretty much, or you can also go down to the operating system layer and kill the network. In some ways, there's some applications that allow it for building latency between two parts of the system. There is again some applications that you can use, and they allow you to simulate. For example, if you have two availability zones and they are really far away, is the syncing between the availability zones gonna catch up? And what happens if the latency increases someday? The network connections are low. Is the system gonna work? So yeah, it's a little bit tricky stuff. I can't tell you a whole lot here, but it needs to be imagined when you get there. So I wanted to do like a short exercise about how we are gonna start building a test, and it will take about 5 to 10 minutes, I believe. So you saw the requirement that we had for X number of users with Y type of hardware and software setup, load models. We have this kind of an application. This then needs to how you're gonna just define the test in terms of let's just take a notepad and try to write how the test will look like and see where we get. Um, you can watch me doing this, but if you are really interested, you can also try to do it in parallel. Um, so, okay, so these are the requirements. How do I define a test? So first thing that comes to my mind is what is the question here that we're trying to answer? Is this defined enough? To me, it looks like I don't have any more information to get from myself, but but it looks decent enough. We can ask more questions, but let's begin with what we have right now. Then we have to think about what type of a test can answer this. As you can see, we have requirements around response times, and it looks like a test in which we need to measure the response times, and it's definitely under the category of performance. And in this, we see that we have only the requirements for the average response times. We don't actually define the request, so we can actually ask the product owners what type of requests are what type of requests are expected for this. So if it's just one type of request repeated over and over again, or if it's multiple type of requests repeated in a random fashion, let's say it's multiple type of requests, then it will fall under the category of comprehensive benchmarks that I showed to you earlier. The next thing that I need to imagine is to solidify the system. What I mean by that is you can run the test with any type of configuration for the hardware and software for the system overall. But once you define a system, then you need to stick with it for longer time to be able to repeat the test. So we need to talk to the developers or to the product owners. So how many nodes for different applications, how many nodes for different parts of the system, what will be the sizes of those of the nodes. If it's like let's say it's not a microservice, or it's not like a containerized application, then yeah, the sizes will need to be defined by us, because in containers pretty much the memory and all of that stuff is already defined. What type of network do we need for this? If you are using something like a standard AWS or Google Cloud or something like that, the networks are pretty much really fast. But if you are in an on-premise lab, then you could have option between 1 Gbps network or 10 Gbps, which is like a little bit more modern. Some older labs still have just 1 Gbps, which can impact your test. So you're still solidifying system. Another thing you need to ask is it how much data is already fed to the system. As I said, we should not start with empty test servers as much as possible, because it will lead to really simpler and easier results than having lots and lots of data. So you need to check how much stuff is on file system. You need to get some of that stuff copied and write it how much of the stuff is in the database. Databases, if there is more than one. There could be some more stuff like to actually get to the actual system. Once you solidify the system, yeah, one more thing. It's not always hardware. It's a lot of times you need to have tunings in place. So what I mean is that there are different let's say memory settings for different different parts of the system. You need to discuss them and solidify and completely agree with everybody else that this is a system that is going to be put under test. So once you have a solid system, that means you have something measurable. It's not going to change in next week or something like that. You can repeat the test for long enough. Then you can start to think about the test. And when we think about the test, the first thing that comes to my mind is a load model that we discussed already. You can try to imagine and choose from the previous discussion. But for example, I decide to choose adaptive load with 2000 or let's say 10,000 requests overhead all the time. And I choose benchmark duration to begin with as 30 minutes, because reasonable amount of time, but it can change depending upon the actual system. Another thing is how to mix, like what, it's more like what will be the ratio of different requests that will be sent, to the server. So you could have certain more important requests that are, let's say 20%, 50% of the request, and the remaining can be 10, 20. You need to define a ratio, because we are building a comprehensive benchmark in which we will have more than one request. It's more like part of the requirements that you need to discuss with people to be as close to the customer use case as possible. After the load model, what you need to choose is like a tool, which we'll discuss a little bit more later in the lectures about how to think about a tool, what kind of tools are available. But it's pretty much, if you choose to build your own custom solution as well, it worked for me several times, because most of the times the applications that we build are very custom, very unique to us, and building like a custom Java framework to load the server is not a bad choice. So is it gonna be a custom solution that you're gonna build, or more like generic tools available? We'll cover this part later, but it's because it can't be covered so quickly, it will take some time. Whatever understanding I have about tools, I will share. Another important thing you need to keep in mind is monitoring. So how do you monitor all of this stuff? You have several nodes that are being tested. You have your test executor. Definitely you need some solutions like Zabbix that I have used in the past. Actually, the thing is more like I have used these tools in the past. This Nmon is kind of a bit old, but and this Elasticsearch is really new. It actually, with Elasticsearch you can build the whole stack of monitoring from the system to the application really easily. But you definitely should think about it when you run your first test, because without monitoring, even if you're trying to build a very simple test, it's not going to give you much value. So actually you have to start thinking about it in the very beginning. And you need to monitor everything, not just the test. Monitor everything from the system to the test executors as well, because sometimes your executors might also run out of memory. Not memory, because most of the tools are already tested, but definitely out of CPU or other resources, like they need more disk, like that. What else? You have monitoring built in. You have the tool in place. Another good important decision for choosing the tool is it should be scalable, because sometimes depending upon the need, there could be millions of users needed. Then your tool might just not scale so much. So always choose something scalable. There are some really good tools like Locust, which scale really easily. While some others might be a bit difficult. I know that Locust can scale, Gatling can scale really easily. I didn't get a chance to scale JMeter so much, but I think it can. We'll find out later. Okay, so we have this. We need to, first what we need to do is to send a single request, not like a million requests at the beginning, and to actually put in place all the checks, which are the verifications, and try to build multiple verifications for the checks, like not just the response codes, but also on the server side, if you can somehow build the checks in the database. For example, a new row is created or not. If that can be possible, that's perfect, because this will give you like when you scale up your request, which is like millions of them, you need to make sure that all of them are passing. Failing requests don't make sense. So just send a single request and make double checks multiple times. Check in the database, check on file system if a new file is created, like end-to-end checks. Also, you can actually return more details in the response. Not like you can ask for more details to the team, to your team, in the response, not just the response codes. So you can parse it and find out if everything that the request was supposed to do was done properly, let's say. Once you have a single request, you need to start sending more requests, like scaling up. Use the load model that we discussed so much that you might be a little bit bored about it by now. So you send more and more requests, and that's when your business begins. You need to start when you send a half an hour of continuous request, then your action begins in the monitoring section. You need to monitor that half an hour. Don't always go for averages. At the end of the test, like after 30 minutes, this is the total, but build time series. Build time series data, I mean what happened during the first 5 minutes and what happened during the last 30 minutes. Because a lot of times the applications, or pretty much always, the applications are slower in the beginning and they catch up later, which is okay because of the caching, but they must not be like slower in the beginning, then they speed up, then they're again slower, because that's not good. That means there was a failure, system recovered. And look for any kind of spikes, or what you can also look for is look for any kind of trends. Sometimes your half an hour test might just lead to like an increasing trend in memory, which might not break the system, but because it's always increasing, it never goes down. That means if you increase the duration of the test, at like in an hour or in 2 hours, the system is going to break anyway. Look for trends. Um, system. Sorry. Uh, Once this is done, you have a test. Always try to build a system, build a process at least in the beginning to store and share the results. What I mean is, if you can somehow even locally host Elasticsearch, if that's, or yeah, usually it's not better to locally host, but uh, host it somewhere in your infrastructure. But if it's not like an option, then you can actually host it locally. It's not that bad. You just need to you'll need to keep your laptop running all the time. But I don't know, let me remove it. Host, let's just keep it host an Elasticsearch server or something like that, and just feed your data to that. At least in the beginning, it will be manual effort, but later it should be like at the same time with some metric beat and file beat, something like that. Later, the advantage of this is going to be it will not be just you who can see the results, and it will be stored for longer time. Everybody should be able to see the results in your team when you build such a test. And for a long term, you should be able to get back to the previous release results and compare them with the current release or previous 10 releases, depending upon how much you um, want to save the data for the sake of saving history, performance history. So yeah, I mean, sometimes the historical data helps to find out. Every time I press control somehow. Cool. You have now a process to store the results. You have sent a request. You have scaled up. I don't think there is anything else that I wanted to discuss in this topic. But yeah, this is how I imagine testing and how it goes like when you are building a new test. We will take a look at different parts, like more in detail, a little bit about monitoring in the coming lectures, some things about tools, um, some things about how to build this kind of a system. But for now, I can share with you the second part of the requirement is to run it continuously and to aim to run it 24 hours. So in my test, I have not put something like this, but here, once you have built the test and build the process to store and share the results, um, put the test in regular execution. And by that, you could use some things like Jenkins or pretty much Jenkins I use all the time, so it should be enough. And trigger some, maybe this is part of the same, trigger some alerts from your monitoring solution. And there is some failing things. Of course, you will take a look whenever you run the test, but it's always good to have a trigger, have an email when requests are failing for the last night runs, and maybe like a summary of what happened. This should be enough for anybody's first test, I believe. Okay, so a task like a small thing that you can try to do is here. What I will do is I will show it to you next week in the next week's lecture. So you have like the weekend to try and play with it if you can try to achieve something like this. And next week I will show you with Java because Java is what I have worked with most often. And you can try to do it with whatever programming language or whatever programming skills you have. So what needs to be done is we need to create a program or kind of a small application which is going to use objects in the memory, but it's not going to free them up for some time. You can simply have an infinite loop or like a really you can in Java you can do it by creating like a list and storing objects like really big objects in the list and not clearing up that list and just adding more and more big objects to the list. So the the garbage collector is not going to clean them up, and you can just yeah quickly speed it up. Try to use a tool whichever you'd like. I sometimes use JVisual or JProfiler or something like that. There is also Java Mission Control with all Java installations. So whatever tool you like, try to hook it up to your application, which means you need to make a JMX connection in case of Java. If you're going to do it in other application, it might be a bit difficult. Observe what happens with the memory actually, because this is a memory leak where we are using more and more memory and not cleaning it up. But also try to carefully observe how CPU actually behaves with a memory leak, because they are related. If garbage collector or whatever kind of cleanup system is in your programming environment, if the memory is not cleaned up often enough, the CPU utilization would go up. And actually, it's a little bit hard sometimes to see if the memory leak is happening or it's just regular memory use. But if it's CPU that's spiking up, then it will be definitely a memory leak. So try to do it. There again, you in Java we get some exceptions, and there is a little bit of difference in exceptions we get in different scenarios. Like out of memory could be also something like GCU overhead exceeded, like garbage collector is working too much. It has too much to clean up, things like that. So observe it and Google it a little bit if you're trying to do it with Java or whatever. And yeah, I will create something like a small program. And so this is it. Hopefully it will give you a little bit more interest into this field, and you will see how objects build up, how you can monitor them. Another really good thing to do could be here is to run one test with memory leak and run one test without memory leak and compare them with some tool like JProfiler. What will happen in this case is that you will see the differences of which new objects are taking more memory. Uh, Comparison is very useful in performance because there will be so many objects, and if one of them is 10% more, you will never understand unless you have something to compare it with. So if you have a previous build and you have a profile of it from the previous build, and you have a profile of a new application build, you can compare and see the difference. But if you're just looking at one portion, which is the new one, you don't have any history, it will be hard to understand which object is being used 10% more, because they look all the same. This is it then. Thank you so much, guys, for joining.